What's up, y'all? This is Hussein Nasser from IGeometry, where we discuss software engineering by example. And today's example is actually database isolation with Instagram. Right, so we take Instagram as an example and try to implement or to explain these concepts of isolation. And today's concept is read committed. All right, so in the previous episode, I'm going to link it here, and you can go and watch that episode where we actually discussed the first approach of actually tackling these problems that we face while we have a database. So dirty read, non-repeatable read, and phantom read. We explained all of those. All right, so just go to this series and just watch those if you want to know what are the different kind of reads here and problems or read phenomena that we have. Okay, and how can we tackle them? So this episode we're going to discuss one style of isolation at the database level, where we actually implement several approaches here to actually fix certain problems. Okay, so this approach is called read committed. All right, where in a nutshell, I only allow users to read committed values. Okay, and we achieve that differently. It depends on the database implementation, really. Some databases using timestamps, some databases uses versions, and yeah, so we're going to discuss this in a minute. But the idea in a nutshell is just if I wrote something and it's uncommitted, don't nobody is allowed to read it as long as it's uncommitted, right? Once it's committed, people start reading, can have access to values. So we're gonna see now what values can we get and what problems does this solve and what this problem doesn't solve, and you can implement. So we can see now that this is an overhead at the database level to implement certain things. Okay, so let's get to work. Let's go to our example here. Instagram, you've seen this picture many times, I guess, right? So we have a like simple Instagram schema here where we have a pictures table, one picture, it has 2 likes, and this is the likes table, which has literally 2 records. Okay, just like this means that this picture had 2 likes, and those are the users who actually liked this picture. Okay, so what we're gonna do here is to see, do I have a dirty read or not? Okay, so let's go ahead and create a new text here. Oh, come on, mate. Yeah, so John is in green. All right, just color coding so we can identify the transactions, really. Nothing fancy here. And Sonsa. Come on, Sonsa. Come on. All right. Sonsa is orange, John is green. And now what will happen is, let's say John attempts to like a picture that is already liked by him. So what will happen is, since John, we have a primary key here, composite primary key, where picture ID and user is the unique identifier. So what will happen is I will fail if he attempts to basically like that picture. So what will happen is we'll always update that picture table, and then we insert a new record in this, right? And for the sake of example, let's say we now have Mr. John Snow here. Execute the first transaction, and that's actually one transaction, but he executed the first query in this transaction, and the query or the SQL statement is update pictures set likes count equal likes count +1, where picture ID is equal 1. All right. Hope you can read that nice and tight here. So that's the first statement. He updated that. And then what happens is Sonsa comes and actually read the likes table, select all, or just select like count from pictures where picture ID is equal 1. All right. Nice. She selects that number, and then so that's just the sequence of things, right? It happens that she had right between the two queries that he's supposed to execute. The next query is insert into likes where, yeah, nowhere, just values 1 and John. So that's the rest of the statements here. That's the whole thing, I guess. All right. So now we're here, right? Update pictures, set likes count equal likes count plus 1 where picture ID equals. So we need to update that. But remember, this is an we're implementing read committed. So we actually store both values. So the original value, which is 2, and then the new value, which is a temporary value, which is 3. And let's just put it here. Right? He just incremented that. And we're gonna use red here, so or green, to indicate that he actually made that change. So 3. 3 is just the temporary uncommitted value. Now Miss Sunsa come here and try to select likes count from picture where picture ID equal 1. And guess what? Now I'm actually only reading committed value. So the database, when executed this statement, the database will return 2 instead of 3 because we only return committed values and 3 is not committed yet. So we just fix that dirty dirty read problem here. And then John tries obviously to execute this statement, which will fail because what? Because of the referential integrity here, and basically this value will be rolled back, right? So that the statement will die. Cool. So now at least Sansa got a correct representation of the values, right? So that is actually cool, right? So that's actually really good. Now we have the same concept, reading committed values, and we have the correct representation. So now we know that we do not get dirty reads out of the read committed values. So if we have a read committed, we do not get that the dirty read phenomena. Okay, do we get a non-repeatable read? Well, let's find out, I guess. All right. So if we change that statement to basically Sansa reading again here, right? We update, which makes which we get 3. Nice. Let's see, do we have a non-repeatable read? We execute that statement, remove that, just execute it again. Let's see if we actually get that. All right, non-repeatable. So non-repeatable is basically this query and this query should be equal, right? Should we give the same value? We execute that, we got 3. Sansa query, she got 2. That's nice because we only read the committed values. 2 is committed. This guy inserts, which fails, right? This fails, nothing happens. And then Gersh selects again, which gives you what? Which gives you, guess what? Gives you 2. That sounds good, right? So it looks like we don't get non-repeatable read, but hold a second. That's because we actually undid that program. We rolled back that query because John is actually is liking his own is a picture that is already being liked by him. So we need to try another scenario and see if we actually get that or not, right? Try to think about it as we start running it here. So let's change the user to Edward, another user who actually never liked that picture. Okay. Delete, delete, and yeah. So what will happen here is change that. Cool. Let's go through this scenario. Update pictures, set likes, count, where commit pictures, and then Sansa sneaks in right there, it tries to query, and then he continue executed the rest of his statements, and then he says, okay sir, I'm done, where he actually commits his changes, says, yeah, let me exit, that's it, I'm done with this transaction. So he's gonna go ahead and commit his change, and then Sansa will read again. What will happen? We're gonna find out, sir. We're gonna find out. All right, so execute that. All right, so that brings us to what? Brings us to 3, still uncommitted. So we're gonna do it in another color. Coolish 3, and then this puppy. This girl tries to read. What does she get, man? What does she get? She gets 2 because we only give committed value, and the 2 is the current committed value. And now we insert a value again. We actually update the likes, which looks cool. There's no error here. So Mr. Edward just liked the picture successfully. Looks like it, isn't it? Right, but let's just make it green. So we know that it's actually not committed yet. Right? It's not committed. Not committed. And then he actually, okay, all right, guys, I'm done. I think I'm done. And looks like he executed all his statements successfully. So what I'm gonna do is commit that. Basically, let's change them to black, indicating that it's actually committed, right? So just write this stuff to the database. Physically write that. Uh-oh. Uh-oh. What will happen now? Mrs. Sansa still working with her transaction, right? And she queries that again as she gets... Holy mama. She gets 3. Uh-oh. So now we actually get the same. Non-repeatable reads are still existing. Ooh, we still have that. So we only solved one thing with read committed. Okay, so we still have the same problem here. How about phantom read, guys? You will guess it, right? I'm not gonna do it, but think about it. Just like if I insert that, if we change this query literally from select count to select all, she's gonna get 2 and then she's gonna get 3. So phantom read is actually still existing as well. So yeah, what do you think, guys? So we fixed one problem, which is dirty area, by actually implementing versions of read committed values. So we still have the 2 problems, which is phantom read and non-repeatable read. We solved one problem, which is dirty read, reading uncommitted values, by actually reading only committed values. So guys, stay awesome and subscribe to this channel to get more software engineering by example. We discuss everything. Type in the description below anything you want to discuss software engineering wise. We love that stuff. We discuss it in an example approach. All right, stay tuned.